presenting on securing and encrypting workloads in Azure today. We have slightly different backgrounds. So Ree comes from a security and a networks background, and I come from an IT operations and software development background. So as we go through, you'll hear our different perspectives on the themes we're talking about in here and how it differs from the IT operations and software dev side and the security and networks side. So in this session, we'll be looking at Azure Security Center and Azure Key Vault. So we're hoping that you'll have some familiarity with Azure and that maybe you haven't looked at Security Center or Key Vault and that you're at least a bit familiar with a PowerShell script. So as we go through, hopefully you're going to get to a point by the end of this to understand that, in our opinion, Azure provides you the tools you need for securing and encrypting your workloads. And we're looking, there are many tools there, but we'll just be focusing on Security Center and Key Vault. So to get started with Security Center, I think it's useful from an operations perspective to talk about why is it important. And so in organizations these days with the cloud, we're getting to a point where it's possible to delegate responsibility for provisioning resources out to business units, project teams, as well as you've got your central IT functions. And if you've got that happening in your organization, then really you want to also ensure that those other teams that may not have the same knowledge that central IT has are also still creating a secure and compliant environment. And so Security Center will give you a single dashboard that will cover the whole of your subscription where you can see what the other teams are doing. As long as you have reader access on those resources, you'll be able to see them in Security Center under this one dashboard. And by having this, you're going to be able to leverage the expertise that Microsoft has built up over the years with things like Azure itself, Office 365, the Xbox platform, where these are quite large deployments, and Microsoft has had to figure out all the hard work around how do we secure this. So Security Center will allow you to leverage that expertise that's existing there without having to do the heavy lifting yourselves. And then because Security Center is part of Azure, where you're actually it can see everything. It knows what normal behavior within Azure looks like, knows what you've got running, and it also, if you've got endpoint protection deployed and diagnostics turned on, then it can see what's happening within your VM as well. So you're going to get complete coverage with it. Now, so Ree.
All right, so you get an idea of why I'm here. I'm not a Microsoft person. Last time I attended one of these, I got an Encarta 95 in my goodie bag. That gives you an idea how long I've been to a Microsoft session. I've been in this game for about 30 years. I'm a networking guy, a CCIE, I'm a security guy, I'm a CISSP. Alex showed me this Azure Security Center about 2-3 months ago. He introduced me, and it was like, I really like what I see there. So I'm coming from a completely non-Microsoft. I'm very new to Azure. But I'm coming from the perspective of saying, I like what I see here, and why do I see it being beneficial? So I come from this perspective here, where you see the prevention, detection, and response. I want to be able to know what's going on out there in the environment I'm looking after. I want to make sure that it's got all the things it needs to have there to protect itself. If somebody's doing something new in that environment, which from the outside in, I want to be able to see that happening. I want it, and know it's happening now. And then I want to have a good idea of what can I do to actually protect against that. This gives you the whole protection, so prevent, detect, and respond. It's a good mantra we basically have for a defense posture. Fits very well with the security ideas of confidentiality, integrity, and availability. But the question then really comes, is there really a threat out there? Because I keep hitting this. So I've just pulled up a few quick stats. I'm not going to go through everything. I'm not going to read PowerPoints to you. But today there's a greater spotlight on security. Just look at the news. Let's blame Russia. It seems to be quite a lot at the moment. Cyber attacks have moved on from when I first got in this game, where we used to do this sort of stuff for fun. Now it's all about profit. The bad guys are getting into your systems now. when they're not really there to say, hey, I want to get hold of the data. I don't want to get hold of your systems because I want to do something. A lot of the times now, we've got players out there who are breaking in, getting control, and then going to sleep so they can sell that access to somebody else when they want it. Let's have a bit more of some stats for some points of where I'm coming from here. Again, I'm not going to go through all this bit, all of the things in detail. But if we start looking at one, sorry, we've gone too far there. Oh yeah, sorry. The Microsoft one, the second one down, I thought was quite interesting, where it's actually pointing, attacks get undetected for like the mean value of 200 days. So that's the point in the middle. To give you an idea of what that really means is, if somebody broke in on New Year's Day, it's the middle of July before you realize. Phishing attacks, they're up. Malware and phishing are the top means of attacks at the moment, and hard intellectual property, which is basically something which is you can take away and actually use, that's up incredibly in 2015. Zero-day attacks have been up. They're up 125% in the last year. That doesn't mean there's more things going wrong. What that means is there's more people spending more time and more effort digging into things. 3/4 of websites out there are vulnerable. Many of the attacks we see are up by 1/3 in the last year. So when we look at what the challenges that we see at the moment, I pulled this from RightScale. You can see the number of challenges that people see with going into the sort of cloud sort of environment. Lack of resources and expertise is right up there at the top. I look at the stuff we get from ISC squared. Here we see the same sort of thing where the expertise is what's the concern about moving into. This is where the barriers are to the comfort levels where people are doing things. But we're seeing an increase in the speed of adoption, even with recently where the New Zealand government are letting the healthcare industry put data offshore in Australia. So, things have changed. We tend to have people who are managing what the technical people are doing, not necessarily always aware of what's there. That doesn't really make too much of a problem as well as we can communicate with them, and that's the whole point, is getting the message to and from the technicians up to the management so they can make valid calls on what's going on. We're really talking about getting the data. We want to be able to present stuff to people who aren't technical in graphical formats, in charts and whatever else that makes sense to them so they can make informed decisions. We want to be able to do things consistently, repeatably, and we want to be able to do some auditing. So basically the world has changed. It used to be a castle type mentality, you protected your borders. Now it's come back into we brought our boundaries inside. SSL is encrypting everything when you're talking out to the world. You can't see truly what's going on all the time inside the data flows you have. The endpoint is everything. Azure Security Center lets you look at what's happening in the endpoint, because you can't always see what's happening between the endpoints because the data is encrypted.
Okay, so what is Security Center? So Reed's talked about the prevention, detection, and response sides of that. And as you can see from the screenshot we've got up here, the top half of the screen is actually concerned with the prevention side of things. And this covers your virtual machines, your networking, Azure SQL, as well as web applications. And then you've got detection down the bottom half, and which is all driven by machine learning. And then to get to the response side of it, you can drill into that detection, and you'll start to see things like a to-do list of recommended actions for remediation for the security events that have been detected. So let's actually dive into a demo and have a look at this in the Azure Resource Manager portal. I'll just refresh the screen here to make sure my login hasn't timed out. Okay, so firstly, where is Security Center in here? Well, you can get to it through more services and Security Center down the bottom here, and I've got that pinned to my favorites. So going in here, what we can see is see that same sort of overview screen, and up in this prevention area, I've got a whole load of resources that that aren't actually that secure. According, you can see all the red up here. I can drill down into these and see that here are my virtual machines, and here's the status of them all. And not just that, but above that, here's a list of recommendations. And one of the interesting things for me was actually, it's not just Windows machines that you can get this deep insight into. So this is a Linux machine that I've got here, and Security Center has picked up that I need to disable support for RDS. I'm not a Linux expert. I don't know what RDS is, but here's a command that I can run, and this is a starting point for me to go, oh, there's something I need to pay attention to here. Let's secure that. So we're not just talking Windows machines is the point there. And then, so all these recommendations that we get over in this prevention section, they're all driven through security policies. And a security policy can be applied at either a subscription level or at a resource group level. And so I've got my subscription level policy here, and it defines recommendations. So it's really important to understand that just by turning something on here, you're not enforcing it. You're just saying, please audit my subscription against this policy. So having endpoint protection turned on here doesn't mean endpoint protection will be deployed to my resources. It just means we'll tell you if it's not, so that then you can go and remediate it. Now, what we're going to do today is I've got two virtual machines spun up, and one has the first one doesn't have endpoint protection installed at all. It's just a blank, fresh off the rank VM. And then the second one does have endpoint protection installed. So what I'll do is I'll show you how we can actually push endpoint protection to a machine, and then I'll also show you what happens when endpoint protection does detect something and how that all flows through. So to start with, if I go back to my overview, and in my resource health, I can see under virtual machines, I've got one down here that the no protection machine doesn't have endpoint protection on it. So I'll just hop on to that box here, and just before any trick you always have to show, look, it's not there. So search for endpoint protection, it's not there. And then I'll come back into the Azure portal, and I can come down here, and there's a to-do list action here for installing endpoint protection. If I had multiple machines, I could tick, 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 across many machines that I wanted to install this on, and then it's just up here to install on the virtual machine. Now, Microsoft works with partners like Trend Micro, and you can choose between a Trend Micro agent or the Microsoft anti-malware agent. So if you're already running Trend Micro in your environment, the benefit here is that the deep security agent will talk to your deep security management console that you've already got. And if you're running on, you might have a private cloud internally, you might be doing hybrid cloud, you might be using multiple public cloud providers. So Trend Micro's offering here would allow you to install it on any of those platforms and have it all coming down into one central management console. I had a talk to the guys yesterday, and they'd love to hear from anyone who's interested. They're downstairs. So for today, we're going to install the Microsoft anti-malware one. And the way that the installation actually works is it uses Azure VM extensions to push the agent onto the VM for you. So you don't need to be logging into all these machines that you want to install it on. You can do it all through the portal. And the other benefit you get from doing that is that when you go to install it, you get a bunch of configuration options here. So if I had 10 or 50 or 100 VMs that I wanted to install this on, I could set these options here and not have to worry about configuring each individual one. So to begin with, we're just going to leave all the options as the default and OK to start that deployment. So now on the, on the second VM, while this is happening, I'll show you what happens when something is detected by endpoint protection. So I'll hop over now to this one. And I've got a nasty little piece of work called the Angler exploit kit with a TeslaCrypt payload. So that's something you might find someone trying to install on a web server to then infect the visitors to your site with TeslaCrypt, which is a crypto ransomware. So in my temp folder, I have, let's get rid of the old, oops, that's not quite what was meant to happen there. So I'm just going to clean up this. And then, so in the zip file is the exploit kit. I'll extract it. It's not been detected yet because it's passworded. So I'm going to extract it here. Password is infected. Oops, type in the box. Infected. And so that's extracted, but straight away the malware client, the anti-malware client, has picked that up and determined that actually it shouldn't be there. And so we can now see in the event log for this machine, we'll find that actually some events have been logged saying that this has been detected, and this will then feed into Security Center and into our detection box on the second half of that screen. So if we look in the system log, it's taking a moment to come up. We will see these two warnings here. So Microsoft anti-malware has detected malware or other potentially unwanted software. It's the exploit, it's an SWF because it's a flash file, and it's an Angler exploit kit variant D. So anti-malware thinks this is severe and it's an exploit and that it was on this local machine and that it didn't detect it through heuristics or anything. It was a concrete detection that this was there. And we can have a look in Security Center and see that there's an actual lag between things being detected by anti-malware and showing up in this section here. And I found that lag is between 30 minutes to an hour. And you can also configure, it's worth noting, you can configure it to have email alerts for you so that you're not always coming in here to check, is there a new detection event that I need to be concerned about? No, you can actually have emails come to you through that. So by drilling down on this detection event, you can see that it's actually aggregated it with another one. There's a count of 2 here. And that's from previous tests I've been doing in the run-up to this presentation. If I drill down onto one of these, Microsoft anti-malware has taken action to protect this machine from malware or other potentially unwanted software. There's a link for more information. And the most important thing to my mind is the remediation steps. So no user action is necessary because it's dealt with it. It didn't install. It actually got caught before anything happened. There's nothing more you need to worry about other than why did it try to install? How did it get there in the first place? So now let's take a look at our other virtual machine, the one that didn't have endpoint protection installed. And if we have a look, we now have System Center Endpoint Protection installed. And so you can see it's very easy to deploy this across your fleet of virtual machines. And now, just have a check. So now I think let's hear Ree's perspective on all of this and what you thought.
Okay, I'm a great believer in to-do lists. It helps me do what I need to do, keep track of what I need to work on and everything else like that. I saw to-do lists inside of Azure Security Center, and I thought, that's right up my street. I like the stuff where we saw the stuff of the remediation. This time it said there was not a lot, you didn't need to do anything. No remediation work necessary. If there was, there'd have been a list of recommendations for you to do, which helps you get right down to resolving a problem really quickly. I like that sort of stuff. I like the idea that when you were looking at the prevention side of stuff, you're looking at setting up your policy of what you want to be able to do out there. It doesn't mandatorily enforce it, but it tells you, you should be doing this. You should be putting this anti-malware on there. You should be doing this sort of security, whatever else. And it gives you a nice little, again, a to-do list. You haven't done this. You should be doing this. Go do this, go do this, go do this. It's very easy to go and click your way through and just press a button, as we saw with the installation of the anti-malware software, and it goes off and fixes the problem for you once it's told you you've got it. So I think the graphical interface you saw, I think that represents what's going on really simply, but with an awful lot of information. You can see how much isn't doing what you want it to do, how much is, where your security stance really is with that sort of stuff. And the monitoring monitors what's happening inside of your environment, so you can really see, okay, what's actually been happening. This time it was just one thing going on. It was a malware, but it could be lots of other things. Azure Security Center monitors what's taking place inside of your environment, so it does the whole, in the networking world I'd be looking at this network monitoring. It's the machine learning. It's seeing way systems should work. It expects it to work. It sees things out of the norm. It lets you know. It tells you if you've got security patches you haven't updated and put in there. Now, it's not like your normal Microsoft, hey, you've got these patches to go and install. This is security-related patches. So if it's there, it's something that's meant to be there and you should be looking at doing. And one of the things I really quite liked was a part to do with crash dumps. Now, a number of server guys I've known in the time, you get a server crash, you get your crash dump, you might spend some time going to analyze and find out what it is with that, but it's a time-consuming job that usually gets pushed to the back because you've got tons of other things you want to do. You never hear of them going and having a look at the crash dump from an application that's basically stopped and restarted. Azure automatically goes away and does that if you have a crash. And if there's a problem it sees in there, sort of the things that I used to do when I was a penetration tester and I'd be breaking something to try and get it to reload with my new bit of stuff in there, it tells you. It turns up on your monitor. It makes it easy to look at doing consistently what you need to be able to do. Consistency, repeatability, accountability, auditing. It's all in there. You can actually, it's built into the system. It's easy to drive. And with my experience of the sort of companies that I've worked in, between very small ones and very large ones over time, I look at what this stuff does, and I actually see that there's more out of the box in your Azure to help you protect what you need to protect than many organizations I've worked with have actually got on site. It allows me to have much more security on there ready, telling me what's going on without having to go buy all the individual bits. It's already there. I pinched this slide from Alex because I just thought it was a really good way of just quickly being able to see what we're talking about here. You've got your prevention. Top, it's easy. You can see what's going on and what you have or haven't done. It warns you straight away, lets you know what areas you need to work on. You then look at the detection. It's seen stuff happening. It warns you straight away there. You can see it nice, easy graphically. And when you need to get to the remediation side of it and respond, there's easy drill down bits to be able to follow your way through and get things working so you can actually fix it. So that's the side basically of what we're looking from the security center from Azure. That's why I believe it should be interesting to you, because you can look at it and quickly understand what's going on And even if you're not technical, it tells you really quickly, either helps you with your comfort zone, this is good, or no, it's not, we know we need to work on something. So the next part we're going to be looking at today is related to Key Vault. Now, before we get too far into Key Vault, wrong button. Right, this is sort of the message we have here is Key Vault isolates cryptographic keys and secures data used by your cloud applications. Okay, that's a pretty self-explanatory statement. Before we go too far into it though, I'd like to introduce you to a few words, concepts, just to make sure we're clear where we're going. So, the first thing I'd like to introduce you to are the terms of P2C and C2P. So, P is a term that's used for plain text. C is a term that's used for ciphertext. Okay, so plain text goes through the sausage machine and comes out as ciphertext. Ciphertext goes through the sausage machine and comes back out as plain text. So, it's often written in this sort of fashion that explains basically how it's going. So your plain text would be no more secret. Your ciphertext would be, well, I'm not going to read that. Okay, so simplistically, this is what we're talking about. P to C, no more secrets, goes through the sausage machine, comes out as your encrypted text. That's secure. C to P, goes through the ciphertext, goes through one end, comes out again, readable. So, other terms we need to be aware of related to Key Vault. There's a key. I won't read through all this lot. It'll be on the slides later. We're obviously short for time. But what we're basically saying here is there's a key. A key is an RSA, 2048 RSA key. You basically put this key into a system. It's in. It stays in. You can't get it out once you put it in there. A secret is a 25k byte block of data, basically, that you can put into an environment that is secure, and you only if you have the right access can you get that data back out again. So there are different security considerations you can put and give rights to access to the bits here related to the secret. So you can have some applications can have the different set or get or create or list. Again, I won't go into the details. We'll leave that for a bit. So to sum up on what we're dealing with here, key I look at as a function, the key function here. What I basically have is you put in an encryption key into a device. Then I can throw at that a ciphertext and get back a plain text, or I can throw out a plain text and get back a ciphertext. It's like a function I do when I'm coding. I look at a secret as being like a variable. It's something when I have the rights to it, I can put a value in or pull a value out. I might use this for putting in SQL connection streams, as you see there, PFX files, other encryption streams you might want there. Right, Key Vault. This is the bit where we put the keys. Now, there's the two sort of parts to this. There's either the hardware version or the software version. The hardware version is supposedly more secure. It's a physical device, which obviously you don't have. It's on the Azure site. But you send, this is where the data gets right down and encrypted into that area. But it's a bit slower. If you use the software version, it's run in a virtual machine. It runs a bit faster, but the end of the keychain is actually back in a hardware device anyway, so there really is not that much difference in security level as far as I can see. They all follow basically the FIPS 140 standard, which, just so you know what that's related to, again, not wanting to get too far into it. If you're worried about your hardware key module that's there, it's the same one all your banks use. So if you're worried about that not basically being secure, the first place you want to be going is down the bank to get your money out because they're running the same things you are. Okay. Again, we got here just covering the final bit with the permissions. Again, another list when related to keys and permissions. You don't necessarily have all rights to a key. What you can have set up for your applications or the individual, however it does, basically all related to your AD, is you can have a different subset of functions. So you might have one application which can write to the key, another application can read from the key, or whatever variations you want to set. So from that perspective, I'm going to hand over Alex so he can show you some stuff on this.
Yep. So Ree's been talking to us about we can use keys to encrypt material, and we can use keys to decrypt material as well. There's some other functions around signing to prove that this is from you, but we're not really covering that here, but Key Vault is very capable of it. And Ree's also talked about hardware security modules, which is a specialized bit of kit that you can store your keys in, and it's tamper resistant. It would rather break, it would rather no longer work if you try to pry it open rather than give away the key material. So from an operations perspective, for me, and also from a software development perspective, what's important here is that in Key Vault, you have role-based access control. So you can have segregation of duties. So the person who's creating the key isn't necessarily the same as the person who is using the key or maintaining the environment operationally. And that means that for me, I can't ever be accused of having leaked key material. So it saves my ass, it covers me. If something happens in my organization and I'm using Key Vault to secure the keys, then as long as I'm not the one that put the key in there, and so you may have a security officer who does that, then I'm in the clear. You don't even look at me for if something goes wrong there. And it gets even better than that because the hardware security modules can actually generate the key for you. So you never even need to see it. Depending on your organization and your environment, that may or may not be okay. Some organizations you'll find would rather generate the key themselves and know that it's done to a secure standard and then import it into an HSM within Azure, and others would be happy to just have Azure generate it for them within the HSM. But the important part is that once it's in the HSM, it never leaves. So that combined with the segregation of duties, from operationally, I think is pretty key in terms of, look, I can't touch it. I can use it, but I can't ever expose the key. And then, so because we're doing everything in Azure, everything is being logged. And so we get the when, where, what, and by who sort of side to logging. And yes, that's great for forensics, but operationally, I also care about troubleshooting. Whether I'm a software dev or an operations guy, if something's not working, I've straight away got logs to go and look at and see what's happening there. And of course, if you have a security incident, you can also go through those logs and see what data may have been exposed if you were compromised. And then in terms of compliance, I don't want to have to try and stand up a FIPS compliant environment. I don't want to do all that heavy lifting. Like, I can use Azure and Key Vault, and it's already all done for me. I don't even need to worry about maintaining the compliance. As long as what I'm doing to interact with Key Vault is compliant, then that's the end of my worries in terms of compliance. And then from a software development perspective, if you use Key Vault, it is going to help you practice good security hygiene, because the ways it allows you to interact with it have already been predefined, and if you use it correctly for the intended purposes, then you're not going to be repeating these same old security mistakes that happen over and over again. So you're not going to have hard-coded keys in your application because you're using Key Vault. At the moment, we see things like SQL injection is still one of the #1 bugs online, and #1 ways people get compromised, and it's because people are still making these same old mistakes again and again. So use Key Vault and practice good security hygiene through that. So how do we interact with Key Vault? There are a couple of ways, and it sort of goes from the easiest down to the most complicated. So via the Azure Resource Manager portal, which is the web portal that we all know and love. And we can also interact with it through the ARM templates. So the ARM templates can be used to create key vaults and also store secrets in them. And then if you want to do a bit of scripting or you're not interested in the web UI, you've got the cross-platform command line interface. So both Windows and Linux are covered there. And then you've also got PowerShell and your language-specific SDKs. So that covers you for things like C# and all the .NET languages. And I'm pretty sure there's more like Node.js. Then if you still aren't covered because you're doing something really specific on some platform that doesn't have an SDK, then you've got the REST-based APIs. So this way, this is the lowest level to interact with Key Vault, and it's through HTTP requests, and you're going to have to do all the heavy lifting yourself, but it's possible. So no matter, as long as you can send a web request off and do hashes and signing of that request, you can interact with Key Vault from anything. So let's actually get into it and have a look. And for this one, we'll quickly have a look at Key Vault in the GUI, and then we'll move on to PowerShell script. So we might do it concurrently, actually. So here's the Key Vault GUI, and again, you get to it just through searching for Key Vault. I've got one vault set up, and the important thing to know about Key Vault and the individual vaults is that all the keys and secrets in that vault share the same access control. So if you've got a number of teams and they shouldn't be interacting with each other's keys, then they need separate key vaults. Because once you give someone a permission to Key Vault, it's for the whole of that vault. But you can have multiple vaults, so it's just a matter of separating your keys and secrets out into vaults that have appropriate shared access requirements. Let's now look at PowerShell. So I've got a PowerShell script here, and I'm going to step through it by putting a breakpoint here. And what we'll do is we'll create a key vault, and we'll use it to store a secret and then retrieve the secret. So if we start off there, we're going to go here. And step one, of course, is going to be me logging into, me authenticating to Azure. And that's popped up on the other screen. Now, you can, being the script, you can actually automate all of this, but I didn't want to have a password out in clear text on the screen for you all. Okay, so logged into Azure, and now I'm going to list my subscriptions. You can see the results of what I'm doing are popping up down the bottom down here. I'm going to choose my Microsoft Partner Network subscription so that all the actions I perform now in this Key Vault script are performed against that specific subscription. And I'm going to create a Key Vault. Now, the parameters here, I'm going to call it my Microsoft Ignite Key Vault. I'm chucking it into my Microsoft Ignite resource group. I'd like it to be in Australia East. And the SKU, I'd like a premium SKU. So in Key Vault, you can have hardware secured keys, like HSM keys, or you can have software keys. And so the software keys are cheaper. You just charge for the operations against them, whereas the hardware keys, it's $1 a month per version of the key that is stored. And to have access to the HSM stored keys, you need to initialize your Key Vault with the premium SKU. There's no other pricing connotation to it. You can still create software-based keys in it, but if you want access to having HSM keys, you need to use the premium SKU. So we'll go ahead and do that. And there's some upcoming changes to the PowerShell commands here that we're just warned about, but we're not putting any tags on our Key Vaults through this, so we can happily ignore those. Now, we get back quite a lot of information here, and the only really important information is the permissions. So for me, I have been given all the permissions to work with keys and all the permissions for secrets. and then I've got a resource ID for my vault, and it's in Australia as we requested. So if we go back to the UI, we should be able to refresh this now and see the Microsoft Ignite Key Vault has appeared. And we can look in here and see that there's one principal with access, and that's me. So we'll go back to the PowerShell script and continue with, so we'll list our vaults, and we can see we've got the Microsoft Ignite 2016 Key Vault, the same as the one we saw in the UI. And we can now, and then we can, I think I've got that line in there twice. Oh yeah, and the important thing here is to note, yeah, so I looked for the key vault, the key vaults that I had in the resource group. I saw my Ignite Key Vault, and as we mentioned before, I've got all permissions to secrets. So to store a secret in Key Vault, you need to store it as you need first to convert it into a PowerShell secure string, and then you can actually put it in. So we'll start off with that. So I'm going to create a secure string called my secret, and then we're going to save the secret to Key Vault. And to do this, we're just using the set Azure Key Vault secret commandlet. We're passing in the vault name. I'm giving my secret a name. I'm calling it demo secret. And then the secret value is that secure string we just created. Okay, so that's in there now. And we've captured the output of that in this toKeyVault variable. And if we have a look at what's in there, we can see down the bottom here, we've got an ID for it. And so you can see it's in Microsoft Ignite Key Vault, which was the vault name that I had. And then it's in secrets, and it's demo secret. Then this last part is actually the version of the secret. So if you have secrets that you want to expire after a certain date or not be present before a certain date, you can do that. And that's managed by having multiple versions of the secret. And when you request a secret from Key Vault, if you don't specify a version, you'll get the current version. But otherwise, if you've got the right permissions and it's still a valid key, you can request a valid secret, you can request a previous version of it if you know the right URI. So if we look in the UI, we'll also see that what we've done is mirrored over here in secrets, and that I have one secret, demo secret, and it's enabled, doesn't have an expiration date, and we can drill down into that, and you can also see that if we had an activation date on it, that would be present there as well. So you put the secret in Key Vault, and now you want to obviously retrieve it to do something with it. We will retrieve it using the get Azure Key Vault secret, and again, you just need to specify the vault name and the secret name, and optionally you could put a version, but I'm happy with getting the current version, and it's the only one we've got. So let's do that. Okay, and now if you are just doing this in PowerShell and you're looking at the from Key Vault, you can see that there's no secret value text provided here. You have to specifically ask for it, which is why we've got this next line where we're interrogating what is the secret value text property that we've just retrieved from, of the PowerShell object that we've just retrieved from Key Vault. And we can see that it's top secret password, which is the same as the text we put in. Now, I thought it was useful to show what happens if we remove permissions from me for the get. So we can actually update the permissions on our Microsoft Ignite Key Vault and remove get. So I'm only going to have list set and delete. And it's important to note for this that the ability to change the permissions on Key Vault are separate from the permissions that you have within Key Vault. So I'm a contributor to this subscription. I can change the permissions even if I don't have so if I remove my get permission, I can still re-add it because of being a contributor to the subscription. So here we go. We'll remove the get permission. And then we'll try and retrieve the secret. and we get an error saying get operation is not allowed by the vault policy, we can put the permission back on. So I see this part here, I've put the get permission back on, and now if we try and retrieve the secret, we get top secret password again. Now, all of that access is logged within Key Vault. So if we go into the activity log, we can see now that I've you can see I've written to the vault, and I think we may need to have all categories. It may be taking a little time for some of the other notifications to come through, but you can audit what's happening to your Key Vault through the access log, the activity log here, as well as control that access to the whole of the Key Vault, as in I'm a subscription owner or Ree's a contributor through here, or you can also change access policies specific to the vault, such as being able to get and set secrets through the access policies here. So you can see I've got all the secret permissions again in the UI. Okay, so over to you, Ree, with why Key Vault?
Okay, so Alex has just shown you how to put secrets into here and get them back out. He's shown you a bit more with the PowerShell, how it can do it, and discussed other ways in which it can be done with other applications. He also touched on the idea that when it came to keys and such like, the owner of the keys, the administrator of the keys, can be a completely different person with completely different rights to the actual application owners and developers, which allows segregation of duties and the whole role-based access control sort of ideas, which basically means your CIO, CISO, whatever else might want to be controlling the keys, which are the crown jewels to a certain extent of that part of the organization. He can and know that only he has access to it. I also like the idea that you get the whole bit which was shown there. You can have this secret doesn't come online until this date, and after this date, it's no longer there. So all that sort of time-based is really good. We covered a number of bits here. It's a moving target, all of this sort of stuff. Recently, they've just added within the secrets the ability for SSL and TLS certificates. So that's something new which has come up since we basically put this together. Key Vault. Too early. Key Vault isolates the cryptographic keys and secures data used by the cloud applications. That was the point we started from. That's what we just hopefully demonstrated to you. We've introduced you to the basic concepts and benefits of Key Vault and allow you to take that idea or those ideas away and see how that can help you within your environments. So, to sum up really what we've been dealing with here. I started from the perspective of prevent, detect, and respond. It's a world that needs that more and more now. Azure Security Center and the whole Key Vault, secrets, keys, all allow you to help work in that environment to those objectives. It allows you to convey your security position easily to non-technical and technical people. The graphics display this very clearly. You can monitor what's happening, see where you are. And my personal favorites, things like to-do lists. When things aren't right, what do I need to be doing? Everyone needs to be security aware these days. The internet is the wild, wild west. We're talking plugging the cloud into the internet, and you're opening yourself up to an awful lot of things. This helps protect you. The internet is a business enabler. Not all businesses are good guys. The criminal side of what's going on out there is becoming bigger and bigger business. And we're involved in an arms race. This helps with that. So, right now, this is where we end up with. Azure has the tools you need for securing and encrypting your workloads. Now it's up to you. We've added these into the slide deck. Links to help you be able to see a bit more of what's going on as well, just so you can see that when you download it. So that's basically where we are.
Yeah, so thank you for coming along. If you liked our session, please evaluate us. Get in and win an Xbox One S or a Surface Pro 4 possibly. If you have any questions, we'd be happy to hear from you, either now or up the front afterwards. We have one. Yep.
Is it chargeable or is it just done as a service?
Right. Yeah. So there's the way the pricing works is there's two. You've got the free and the paid, and off the top of my head, I'm sorry, I can't remember specifically for the endpoint protection. But it basically comes down to if you want deep inspection into your node, then you need to use the paid version. And if you don't want deep inspection in, then you can use the free. And so in future that Microsoft has been talking about, they may extend this deep inspection capability into things like Azure SQL with other specific parts that will apply to that. But to get the specific for your question, I wouldn't want to put you wrong, so I'd say visit this link at the top and you'll be able to see. Yeah. Anyone else? Yes.
Is it possible to grab the encrypted string off the Azure vault and store it locally?
Right, so are you talking about when you're using a key or?
No, sorry, so the actual secret.
Oh, right, the secret, yes. So, no, I don't believe so. No, all you'll be given is a URI, which refers you to this version of the secret. You'll never be given how Azure stores that secret.
Right, so we wouldn't be able to store it locally and then use the key to decrypt on command.
So, yeah. So for that sort of scenario, you'd want to use keys, not secrets. So you could use a key, so you could have plain text, pass it up to Azure for the encryption operation. It would encrypt it for you and return the ciphertext. You could store the ciphertext locally. And if you're doing something where you're encrypting a lot of data, you might want to use multiple sort of key scenarios. So asymmetric keys, which is what Azure is using currently, or currently supports in Key Vault, are slightly slower than symmetric keys. So if you're encrypting a lot of data, you may want to use a symmetric key locally, and then actually that becomes your content encryption key, and you'd secure that key with a key encryption key, which would be asymmetrically encrypted and stored in HSM. Does that make sense?
You're getting into the area of keychains now.
Yes. Right, but as long as the end of your keychain, like as long as you're following good practices in your keychain and the end of it is in the HSM, then you should be good to go. Yeah. So it is based on machine learning, and you've got the controls you have are just around your security policies. So if you set security policies that say you would like to know about abnormal network behavior, then it determines what's abnormal for your subscription. So for example, we've had machines sitting there exposed to the internet with their RDP port open, and it's not raised any red flags. But we know that the IP ranges for Azure are being scanned by people looking to brute force RDP machine, open RDP connections. But then when we did that ourselves, and I hammered a box with encrack, and then I then logged into it successfully later, that triggered a detection event for me. So you don't get to control what it thinks is normal or abnormal, but my experience has been it's really good at signal to noise. You don't want to have a lot of detection events for routine stuff that everyone pretty much knows is happening. But if someone's been hammering on the front door and finally gets in, you really want to know about that. Does that answer your, yep? Right.
It's very much in the mindset of the old IPS, IDS sort of thing. When you're putting something first in, you're monitoring what is and getting to learn your traffic profiles. It seems to do it in a very intelligent way, though. And again, I quite like the idea. One of the things I've seen many times when from people watching what's going on from a security perspective is they love to log all the failures of somebody logging in. They don't bother to log the successes. So if you've been watching failure, 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 that's good, but they don't record finally they got in. This was picking that up. That I thought was really good.
Yeah. Any other questions? No? Okay, I think that's it for us. Thank you for coming along, and we'll be down the front. Yep.
I can't shoot them anymore. That long black cloud is coming down.